Welcome to aminacademy.com. In physics, let us discuss about parallelogram law of vectors. If two vectors acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal passing through the common tail of the two vectors. Consider the figure. Here, let O, OA and OB is two vector and C is the endpoint of the resultant vector. Now OA is vector P and OB is vector Q, and the resultant of these two vector is vector R. Now from C, drop a perpendicular to the base OA and meet at 90 degrees. Here the name as D. Now here in right angled triangle OCD, here the triangle OCD, OC square, that is hypotenuse square, OC square equal OD square plus CD square. Here, since OC square equal, OD is OA plus AD, OA plus AD whole square plus CD square. By expanding, OC square equal OA square plus AD square plus 2 OA into AD plus AD square plus CD square. Now from right angled triangle ACD, we can say by Pythagoras AC square equal AD square plus DC square. Now keep it this as 2 and this is 1. Substitute this 2 in equation 1. The 1 gives OC square equal OA square plus AC square OA square plus AC square, OC square equal to OA square plus AD. Here OC square equal OA square. After that, AD square plus CD square is AC square, that is we write that one, plus 2 OA into AD. Keep it this as 3. Now from triangle ACD, right triangle ACD, now CD equal here, put theta here, AC sin theta and AD equal AC cos theta. Okay, put it this 4 Now substitute this 4 in, suppose that 4 in here OC square. We will substitute that all values of CD and AD. Now keep it, this is 4 and this 5. Substitute 5 in then OC square, that we have to substitute in 1. We'll get OC square equal OA square plus AC square plus 2 OA into AC cos theta, because we have AD equal to AC cos theta. Instead of that, we substitute AC cos theta. Now we know that now here OC equal to R, therefore we can write R square equal OA square is P square, AC square is Q square plus 2 OA is P, AC is Q and cos theta. Or we can write R equal square root of P square plus Q square plus 2 into P into Q cos theta. Now this is the magnitude of the vector. Now we'll find angle of resultant. Angle of resultant, how that means, let this is the alpha angle, means resultant force with the horizontal is alpha and angle between the two vector is theta. Now in triangle OCD, here the triangle OCD, right angle triangle, tan alpha of a tan alpha equal to opposite over adjacent, CD over OD, CD over OD. CD write as it is. Instead of OD we can write OA plus AD. Further, CD we have, CD is AC sin theta over OA equal to P and AD is AC cos theta. Further, which is equal, AC is a resultant R sin theta over P plus AC is Q cos theta. Now we can find the angle of resultant for all angle of resultant vector to the horizontal, that is alpha equal tan inverse of Q sin theta over P plus Q cos theta. Now some cases we will discuss. Here, when the vectors are in same direction, means here theta equal to 0, means look here in parallelogram, if theta equal to 0 and O vector P and Q overlap, that means theta equals 0, then also sine 0 is 0 and cos 0 is 1. Now we'll substitute the resultant. Now R equal P square plus Q square plus 2PQ cos theta, which is R equal further P square plus Q square. Cos 0 is 1, therefore 2PQ, 2 into P into Q. Thus, resultant vector act in same direction as the individual vectors and is equal to the sum of the magnitude of the two vectors. After that, we can expand this for, we can simplify square root of P plus Q whole square, which is equal or equal square root of P plus Q whole square is only P plus Q, means resultant vector is addition of two vectors. When second case, two vectors act opposite direction, in that we can give theta is 180 degrees, then we will apply, therefore cos 180 degrees minus 1, as well sine 180 degrees 0. Now we'll apply, then R equal square root of P square plus Q square minus 2PQ, because cos 180 is minus 1, therefore minus 2PQ, which is further equal square root of P minus Q whole square, which is equal P minus Q. Means the resultant vectors has a magnitude equal to the difference in magnitude of two vectors. Suppose two vectors act opposite directions, then resultant is subtraction of each vectors. When next case, vectors are at right angles, theta equal to 90 degree, from that we can get cos 90 equal to 0, sin 90 equal to 1. Therefore, resultant vector R equal square root of P square plus Q square plus 0, means resultant is P square plus Q square. Therefore, resultant vector R is vector act at an angle alpha with vector P, means resultant is square root of P square plus Q square. Now let us discuss small things about subtraction of vectors. The subtraction of a vector from another vector is equal to the addition of the vectors to the negative of other, means vector P plus vector Q, vector P minus vector Q is equal to vector P plus addition of minus vector Q, which is equal vector P minus vector Q, which means we can show one here, one vector is P vector is like and Q vector is in opposite direction, then both vector is added, which means P plus minus Q equal P minus Q. If vectors are in different directions, suppose this is vector Q and this vector is vector minus P, then this vector equal vector Q minus vector P.